Hey y'all, Data Guy here, back with yet another viewer request video. And today I'm going to be going through how you can build a migration pipeline using Airflow to bring data from your Minio environment, but the same principles will apply for really any kind of object storage you're using. So bringing it from object storage and storing it in a Postgres database and doing it in a very repeatable pattern where you don't necessarily need to know the characteristics of that Minio database, right? And so what we're going to do is show you how to build that using Airflow so that you can start using this again to mass migrate all of your data from whatever object storage you're using into something like Postgres. So if you like these videos, please like, subscribe, consider joining my Patreon for even more content and content earlier as well. And without further ado, let's get into it. And so the first thing we're going to need to do is just build a new blank Airflow folder for us to use. So we'll just go into desktop and then repos, make directory, Minio, Postgres, migration. Awesome. And then we'll cd into there. And then we'll run astro dev init to generate the basic file structure for our Airflow environment. Then we'll go in and actually open up this Airflow environment. So Postgres migration, and boom. Now we're ready to get started. And the first thing we're going to do, as we do with all of our DAGs, is install some required packages. So here we are going to need the Postgres, Amazon, and Pandas packages. So here, just delete the pip install, but that is effectively what's happening. So if you are pip installing your requirements for some reason, this is how you'll do it. And so here, just install basically these three packages within your requirements.txt. And then all we'll do next is then just go and start creating our DAG. So here, call this Minio migration DAG.py, and we can start building it. The first thing we're going to do is just import a whole series of packages and requirements. So here, the standard date time, time delta, time typing for lists, dictionary, any optionals, just different types of typing types. Fun word to say, right? And then we're also going to bring in the Airflow decorator, so using the Tassel API to make it a lot easier to structure our DAGs and a lot more natural as well. Also a Postgres hook for interacting with Postgres, S3 hook for interacting with and pulling data from S3, the Airflow exceptions so we can raise and throw specific exceptions for different error types, Pandas for creating data frames, NumPy for manipulating them, and then IO, this is for actually interacting with Minio and using it as that object storage buffer, and then logging and JSON as well, so logging, so you can imagine what that is, and JSON for collecting and interacting with and manipulating JSON response data. And then we also finally have enum, which is a way to create symbolic names bound to unique values, but essentially we're going to be using this to create some unique value tokens. So then what we're going to do is at the top of the stack is define two kind of configuration classes, just ways to store all configuration details. So here, Minio connection ID, whatever that will be. So make sure you go into the Airflow UI and create your Minio connection and your Postgres connection. Those are the only two connections you'll need to run this DAG effectively. Then also point it towards the correct Minio bucket, the prefix for the data you actually want to pull from that Minio bucket, the schema where you'll be creating your Postgres table, which is the name of the table that you want to create. So just having a generic imported data table here. We also have we're going to create a staging table before we clean and store the actual data we want to save in the imported data table. And then we have the Postgres error table as well. So any kind of import errors we're actually going to save here just in case we need them downstream. Then we'll also have some parameters for the MAC for our data quality checks and just that we're going to run. So here, setting the max null percentage that we want to expect per column, the minimum rows per file, so making sure that we don't get any empty files, and then just setting the data quality columns that we expect to be getting. So here are the expected columns that we want to check from this data set that we're going to be pulling from Minio, and then the required columns that need to appear within everything. So making sure that, hey, if these columns don't appear, we don't want to ingest this data set. Then we just have this validation status where we're just going to have three different types of validation status based on whether or not our data that we're importing passes our data quality checks. And the reason why we're incorporating data quality checks here is it's a lot smarter to import to have data quality checks on import rather than trying to run them within the database, because you're going to save a lot of money if you don't do the downstream processing on data that is already bad. Then we're just going to set some standard default arguments, so just owner, depends on past, emails, retries, and just setting a one retry of 5 minutes. So those are all our kind of clerical, just variables we need to set, and then we can start building our DAG. So first thing we'll need to do is just declare our DAG body. So here, DAG ID, set a description, and then what we'll do is start building our DAG. And I don't know why it keeps moving down here. But essentially the first thing we're going to do is build our first task, which is going to be just creating a set of tables within Postgres. So this is going to create, this is assuming that you haven't created any of these tables already within Postgres. So if you already have a staging area table set up, you don't need to run all this, but this will create a full set of tables from scratch. So our main table, index, the tables, create a staging one as well, where we have source files, and then obviously our main table has all our columns broken out. And so here you would create this table to match with, hey, whatever columns you actually expect to be stored there. I'm just using kind of some generic placeholder names here right now. And then you'll see we're creating an index on our source files, and then also creating a staging table for all of our source files. So and then we also have our error tracking table too. So if any errors are thrown during our ingestion process, we're going to store them. We're going to store the details around the file that caused that error here. So not the data itself, but a reference to the file. And then you'll see this is just going to create these 3 tables in sequence, and then return the names of these tables as well, and set those in the config. So tables created, and then you'll see config, and it'll say, hey, these are the tables that we created. You can see it's pulling from that config class that we set up here, rather than needing to pull in all these variables, in an array to each task. That's why they're in that class. It just makes it easier to say, hey, I want to pull from this set for each individual task that needs them, because there is some variability in which variables are needed for which actual task. So now that all the tables are created, the next step is going to be creating a list function to list all these CSV files that we're going to need to process within the Minio bucket. So this isn't designed for just a single, Minio file. This is meant to be a bulk migration tool, right? So here we're going to list all the files that are found within our Minio bucket. So initiating an S3 hook, assuming we're using S3 to back Minio. And then here what we're going to do is just list all those keys. Hey, if there's no files found, return no files found, but otherwise return an array of all of the files that we need to process for downstream. And so then our next task is going to be quite complex. And what we're basically going to be doing is validating the file structure and making sure the files that we're importing are complicit, or are compatible with what we expect to be getting from this Minio bucket. So again, doing data quality checks. If you don't want to have this happen as part of your pipeline, you can remove this, but I highly recommend it, and so I wanted to show it. And so here what we're doing is for each of these files, you can see here from this file key, we're going to be reading each file's body, reading the CSV, making sure that it passes our validation checks. So is checking if the file is empty, making sure expected columns are there, checking for required columns with no nulls, also using that check null column percentage for all the columns, and then also checking for any duplicate rows or data type validation, and then here we have, for any kind of values that can't be converted, or any kind of issues that, so if it isn't an expected data type, it'll try to convert it to the expected data type. Otherwise, it'll raise an error saying, hey, we weren't able to validate this data. And then, here you'll see a raised exception, but as long as everything goes correctly, then it'll just return the validation results, which will just say, hey, this all went successfully. Otherwise, you'll have a link to the file key and the actual validation, file validation step that failed there. Then our next step is going to be transforming and loading all of these data sets. So we need to basically, transform and load the data into Postgres using the 2 hooks in conjunction with each other. So here what we're going to be doing is initiating 2 different hooks. So first skipping files that have validation errors, but then initiating connections to Postgres and to S3, reading the file from S3, getting the contents of the file, reading that into a pandas data frame, generating a batch ID for saying, hey, this is the batch that we're using, and then also storing original row numbers just in case there is an error and we need to revert back and say, hey, this row had a problem with it. Then what we're going to be doing is actually going through and checking, hey, and transforming each row. So appending these rows into our Postgres database, or into a moving it from the data set into this kind of batch data frame that we're going to be using to actually upload the data into our Postgres environment. Then, if there's any errors, logging those errors to the error table, and then loading all the valid rows into a staging table. So here we have this Postgres hook run into that Postgres staging table using truncate, so clearing the staging table of any previous data so we don't double upload any data that was already loaded before. Then we're going to insert that data from that CSV from that data frame we just created into Postgres. So here target fields rows equals valid rows, and so these are the rows that we just cleared as valid. So appending each transformed row there. And then once that data has been inserted, we're then going to be moving it from that staging table into the main table, but also applying validation there as well. So making sure that hey, we're not moving any broken values there. Only column 1 into column 2, and then as long as it exists. So running this hook to actually move the data from our staging into our main table, and then returning the file key, so saying, hey, this file was successfully uploaded into our Postgres main table, status success, the amount of rows that were loaded in there, any errors that might have popped up, so any rows that were unable to be loaded, and the batch ID. Now, if you look closely there, you notice that our transform function wasn't actually defined yet. And so that's what we're going to define here. So actually applying transformations to a single row to make sure it is the right format for Postgres, because there's slightly different data types we're going to need to use. So here we're doing the basic field mapping and go, hey, from from just base CSV file, extracting that into this transform column 1, 2, 3, stripping any unnecessary characteristics, converting it into an integer, into a float. So you're not most times going to be uploaded directly from a data frame into a Postgres table. You're going to need to do some kind of conversion of data types. And so here you're seeing that transformation take place. So doing, again, further transformations outside of just validating the data, but now getting into the right shape for being uploaded into your Postgres environment. So here, running, hey, making sure there's no null values, any kind of custom transformations. Let's say if I wanted to replace any spaces with an underscore there, or categorizations based on column 2's value. So if you're under 100, you're low. If you're under 1,000, you're medium. If you're over that, you're high. And then we're also going to calculate data quality scores, and which we'll show you in a second as well, and store the transformed data set with a defined data quality store, saying, hey, we can actually now go back and check the data quality here as well, rather than just being a simple yes or no. Also saving the metadata, and then just also making sure that any transform fields were not made empty by this process. And then the next step, as you might imagine, by the fact that we need to calculate the data quality check, and I referenced that there as well, we're going to define another function for calculating the quality score. And so here, this is just basically going to saying, hey, you get a score of 100 or 1, and then we're going to assign penalties based on if you have missing fields, if you have suspicious values, and if you have any of those kind of suspicious values, then we're going to return a score based that says, hey, this is how high quality this data is, how much we actually trust it. Then what we'll do as well is we're going to run some post-load data quality checks too. And again, this is totally optional. And this is basically just going to go through and do some transformations on your Postgres table that we actually created. So again, don't need to do this. This is really just another way of showing you where you can do data quality checks. So instead of, a lot of it is just the same data quality checks that were done before, but now they are just going to be happening, sorry, wrong, copy paste. They're going to be happening within the Postgres table, so you have a little bit of optionality here in how you want to do it. And so here, we have calculate quality score, and we have it twice here. Sorry, I've screwed myself up quite. There we go. Awesome. So here, calculate quality score, and then We have our data quality checks again. So run quality checks. And boom. So this is basically just running a lot of the same data quality checks, but with Postgres style language. So here having count greater than 1, having no null values, having required fields, the data freshness, quality score distribution, a lot of the same operations, but just now being done in SQL rather than in Python. So again, just about the optionality there of, hey, do you want to have it run in SQL or in Python? And then, for checks and checks, just making sure that they passed all that and iterating through the different rows there. Then our last task, generate a summary report. So, we want to have just a nice clean printout of, hey, total rows loaded, amount of files, processed, failed, overall status. This is something that's meant to be used when you have hundreds, thousands of files. So going through and checking every operation isn't really tenable. So this is a great way to just say, hey, here's an aggregate score, and here's a list of any issues that came up that I can go check individually. So those are all the tasks, and then the way we're going to map this all together is through heavy use of the .expand method. So if you don't know, .expand method allows you to run operations in parallel for a given list of, given array, and it'll say, so in this case, for every file that we're uploading, all these jobs are going to be happening in parallel. So all those file structures will be happening, validations will be happening in parallel, transforms, loads, quality checks, summary report, everything happens in parallel. So you don't have to, worry about, hey, if you're using Airflow right, this can scale out. You have 100 files. This can scale out, process all those 100 files at the same time using 100 different workers, and it's effectively going to cost the same as if you just use one worker for 100 times the time to process them all in sequence. So here you can see, just all the use of the .expand method there, but that's all I have for you today. Just want to show you a nice, cool, repeatable pattern for migrating data from object storage like Minio into Postgres, because it's a very common pattern and it's something that's really annoying to do. So I wanted to help anyone out that needed to do. So I hope you enjoyed this video. Hope you have a great rest of your day. Data Guy out.